Well, here we are for some more diesel stuff today. I hope you guys are having a good Monday so far. Although this video is going to be released early enough in the day that your Monday probably hadn't started yet if you're starting to watch it about the time it comes out. If you're partway through your day, I hope you're having a good day. That's the whole thing. So I figured I'd hit you with some more diesel stuff. This is I've got just a little touch of something I want to show you. I started talking about the variable turbochargers, variable geometry turbochargers for the Power Stroke and the Duramax, and I mentioned the Cummins one, but I didn't actually tell you how that one works. And this one right here, this is a video of how the Cummins turbocharger in 2007 worked. I don't know how much it's changed between now and then, but that's how. Well, you notice how it makes the turbo spin faster whenever it closes up. It basically is it moves the centerpiece. See how that centerpiece moves? It's pretty cool, isn't it, the way they did that? It's only got that one moving part as far as what it does to change the size of the turbo. So whenever it goes in, it's basically when it pinches that down, that gas goes through there faster. See how it slows it down whenever it gets more speed? More space in there. And so that's just a pretty cool way that that thing works. And I meant to describe this to you last time, but I figured I'd go one better this time and show you a video of the way it worked. And that's a pretty cool thing. That's basically something I found from Cummins. Okay, now this right here, look at the difference. The only difference you're going to see between the Duramax turbo and the Power Stroke turbo in the early 2000s was that the Duramax turbo is basically got a sensor here so that this little egg-shaped lobe can tell the engine controller where this oil piston is basically at in relation to where the vanes are. Now that's not available on the Power Stroke. The same lobe is here. As a matter of fact, the hole that this screws into, you can actually screw a plug out of it and see this. And one of the ways that the Power Stroke tells you to watch, they want you to watch this while you're commanding this turbo to change vane angles. So you can tell, you might notice that little peg that's off center on there. As this rack runs, it's basically going to change these turbos. But this is the same. Now this one here has got some stainless steel components that this one doesn't have, but the design and the size and the shape of it is the same, and it's a Garrett turbocharger. Well, this one here has got some GM name on it, but the long and the short of it is that's an accurate diagram of the early 2000s. Now this one here was on the 6-liter, that one there was on your General Motors 6.6. Now this is the 6.7 turbo. You notice how they've maintained, they have the same exact oil piston here and the oil control, and they've actually got a little rack here on that one. This is a 6.7. It's it's going to spin 2 turbos. The part of it that's got the exhaust going through it over here has got vanes, and these are the vanes. That's a cutaway of that one there. And incidentally, this one, that 6.7, has got a waste gate, just in case it cannot do enough with the vanes to limit the boost and that sort of thing. So whenever it opens these vanes up and lets more through there, this spins slower than it does when those vanes are pinched down. Of course, you're creating a little exhaust back pressure there, but you're also spinning this faster, which spins the impeller faster. This is a turbine, that's the impeller. The impeller is what forces the air in there. All right, enough about those turbochargers. That's an interesting little graphic I figured I'd hit you with there. Now, diesel in general, the Bosch fuel pump injector, there's got to be pressure in that chamber feeding these, where the little pistons squirt out those little bursts of fuel wave to pop the injectors. Whenever the pressure goes into the injector at a certain pop pressure, it basically causes it, when the pressure reaches that certain pop pressure, it pops that pedal up against its spring and fuel sprays out into the cylinder. Some of the pop pressures are higher than others, and there's pop pressure testers we used to have a long time ago where you would watch your gauge while you were working, and you would notice what the pressure was when that injector popped, and that way you tested the injectors that way, and you looked at the spray pattern and looked at when it popped and all that. But you had to have the spec for when it was supposed to pop so you'd know if it was working right. The pump uses internal cams and plungers to send these pulses through these lines, and almost like a distributor, almost like a fuel distributor. Of course, the old K-Jetronic fuel distributor on Volkswagens didn't put pulses through there. It just increased the pressure, and the injectors were basically atomizers on those. But on this particular one here, and all of the ones that are similar to this basically sends out pulses at the right time to operate the injectors. You might remember, if you've ever bled the air out of the old diesels, how you'd have to go and get your 5/8 wrench and brace that line loose there at the injector and spin it over until you started seeing fuel there, and then you'd tighten it up and it would begin to pop those injectors and it would begin to deliver diesel, and eventually it'd fire up like that. Now, diesels in general, every injector feed line on a given engine has got to be exactly the same length. So if you were to straighten out each one of these lines and measure them, they would all be exactly the same length. The radius of the bends in the lines cannot be tighter than about 2 inches. And even the clamps that hold these have got to be specially spaced and placed by fuel injection system engineers. I worked on a diesel one time that had a misfire, and the cylinder that it was misfiring on, I noticed somebody had just taken some line and had built an injector line and connected it from the injector pump to the injector with no regard for the length of the line. They just, made a straight shot over there. A lot of times you don't think about it, but the reason these things, they've got these funky curves and all, it's kind of like the headers. You know how headers, all of the exhaust pipes, one coming from each cylinder, all of those have got to be the same length, and then they go into one collector and it makes an extractor exhaust and all that. Well, exhaust is slightly different than this, but the point is, every one of these lines going from the pump to the injector has got to be the same length as every other line, because if it's not, you're going to wind up with a misfire. The timed pulse results in popping the injector is based on that high pressure wave that's traveling from the pump to the injector. A shorter or a longer line on any one injector will cause a misfire because it changes the injector timing. It will pop at the wrong time. A lot of times we don't even think about that, the ones of us that work on diesels. Now that's the way it was when you were doing that. Now, at top dead center, on a hot 6 liter, the piston comes to within 7/1000ths of an inch of the cylinder head. On the old Deutsch diesels that had 6 separate cylinder heads, and you actually had to set the, use shims and stuff to set the cylinder head so that it was at 40/1000ths of an inch. When the piston was barred over and it came up, you'd bar it over, you'd put a blob of solder on top of the piston. And then you would turn the piston over, and when it squished that solder, whenever that piston came up and back down, you would mic the solder, and if it had too much, if it was more than 40/1000ths of an inch, whatever that spec was, you would take a shim out, and if it had too much, you add a shim to it. But all of them actually had to be shimmed up. Now, there was an engineer that I spoke to at the Craftsman truck race when I was in the hospitality booth, and he was the one that told me that these things, when this piston swells up and everything gets hot and those clearances get tighter, he said sometimes you would actually see signature marks on these head of these pistons where they had actually made contact, with parts of the cylinder head of the valve or whatever. You might notice the little combustion chamber is actually built into the piston, and when that injector on this 6 liter, whenever this pressure is multiplied by that, to pop that, when that pressure comes down here, it pushes, it actually pops that thing open because of that, that spring's holding it. And the spring is calibrated so that it takes 1800 psi, whatever it is. Some of them go a lot higher than that, but I just pull that number out of the air. Anyway, you got to recognize just how close that diesel piston comes to that cylinder head when it's at top dead center. And that's why, your injector timing is going to be, actually, it puts the fuel in there on the way up so that it will fire on compression, because you get 2 pounds of compression for every, you get, if you've got 450 pounds of compression, you're basically increasing the temperature 900 degrees, because it's 2 degrees Fahrenheit per pound of compression. And that's one of the reasons that you got like 18-to-1 compression ratios on these diesels instead of what you're used to on a gas burner. Now this is this standpipe actually delivers the oil pressure from the high pressure oil pump to this rail. The purple is your high oil pressure, yellow is splash oil, this right here is exhaust, this is intake, white's intake coming in. So you got splash oil here, You got, and lube oil pressure is not visible in this picture, but it would be orange if it was. But so there's your really high oil pressure. That high oil pressure operates on this intensifier piston, and that's what operates that injector. And so that's giving you sort of a cutaway look at the 6-liter. This oil rail up here, though, is really important because it is going to carry much. Now, a lot of times when you're dealing with super high pressure, you don't have a lot of volume, but you got a lot of pressure. Sometimes these standpipes on the earlier would split, and when they split, you'd lose the pressure and you'd have a no start and that kind of a thing. You could actually take the oil rail pressure sensor out and put your, with the valve cover off, and put your rubber tipped air blower in there, and if you blew on that, you would hear that air pipe, that split air pipe going, and all that. So that's one of the ways you could find that, just like you can air up your oil gallery on an engine and find out where the oil pressure is being lost at on the low side. But anyway, now there's a part that is still used but not discussed, and a lot of people don't even know this thing is there. You notice there's no fuel pump here on this one here, but there's a diesel thermal recirculation module. Well, I think I put this wrong. It's supposed to be DTRM. And instead of DRTM, I screwed that up. But the long and the short of it is, that thing has got a job to do. Now this is your bottom of the tank. These nibs, and a lot of these vehicles, you might notice, are got a spring-loaded fuel pump that's pulling right off the bottom of the tank. That way, before there's enough water that condenses, water condenses if somebody runs the thing low on gas on with amber diesel. And so contaminants and stuff are pulled in through here, so that they're dealt with by the filters that are in here. That's a picture of those filters in there. There's your little nib assembly. Now there's your DRTM. All right, fuel that's been warmed by the engine and is coming back to the tank on the return follows a route controlled by a thermostatically controlled spool valve in the diesel thermal circulation module. And that's that little module down in there. It's down in the bottom of the pickup unit in the tank. That's where your float is and all that. That right there, and we'll talk about that in just a minute, its internal thermostat's exposed to the temperature of the fuel that has already passed through the screens, and if the thermostat device is cold, it contracts to allow the warm return fuel to pass through the spool valve and enter the fuel line. So basically, you're mixing the warm return fuel with the cold fuel that's being pulled out of the tank, because warm diesel fuel does a lot better than cold diesel fuel. So you're basically using that module to keep the temperature of the fuel at an optimum, Celsius or Fahrenheit or whatever you're looking at. I don't know what that number is, but they're basically looking to keep that thing so that the diesel will always be a nice even temperature coming out of there instead of getting real cold diesel fuel. Cold diesel fuel doesn't do well. You're basically wanting your diesel to be warm, and this helps the return fuel coming back in there to mix with the fuel that's being sent out so that it's always nice and warm. Now, if the thermostat is too warm, it expands and pushes the spool valve closed to force the fuel out of the duct bill. We're going to try to avoid any kind of vapor lock, right? That duct bill puts the return fuel out underneath the fuel at the bottom and underneath there, so that it's not exposed to oxygen. You might remember, if you've worked on diesels, how that tar winds up getting on the screens in there. One of the reasons that happens is if that fuel sprays out above the fuel level in the tank so that it can oxidize, it turns into tar, and that clogs things up. And that's been a problem for a long time, but some smart aleck figured out, well, we're going to run this out underneath the fuel so that it's always squirting out of the bottom of the tank. And that little thing's just got a split in the end of it so that whenever it sprays out, it goes like that. All right, now on the 6.7, there is also, on this diesel fuel conditioning module, a thermal recirculation valve that basically does the same job, only it's a little bit more complex. You got a fuel temperature sensor here, you got a fuel delivery sensor here, and there's your primary fuel filter, which stops, stuff. This thing right here they're really, really fine filters and all that. And there's your diesel fuel conditioning module. See that little dotted line right there. Low pressure fuel pump is built into it, and so you got a high pressure fuel pump over here. We're going to talk a little bit more of that later. And you notice the rail, this late rail on that side has got your fuel pressure sensor and your fuel pressure control valve right there. So basically you're looking at your volume control valve is on your pump. But the pressure control valve does more when the engine is cold than it does when it's warm. But whenever it warms up, the pressure control valve, they call it PCV, which is kind of dumb because you're thinking positive crankcase ventilation, right? But anyway, this one here is basically going to fine-tune that rail pressure on the 6.7. All right, and then let's see what else we got there. That's about it. You can read these right here. You can freeze that and read it, you know, at your leisure, and you know, study the schematic and all that kind of stuff. That's what this thing looks like on the truck. This diesel fuel conditioning module, and it's mounted on the frame under there. You notice the one on the 6-liter, if you remember, was a horizontal one. This one here is actually vertical, but it's got everything in it that you see right there. And this right here is the, see that pressure control valve and the fuel rail pressure sensor here, the low fuel pressure switch. I'll tell you why that thing is there. You might know, or you may not, that if you run a diesel with a low fuel pressure feeding the pump, or if you run the injector like you're running out of fuel, if you run one of these diesels out of fuel that's got this high pressure, you know, the electronic diesels, it will ruin the injectors in short order. That's why this thing right here, that low fuel pressure switch, is supposed to have a certain amount. I think if it's supposed to have between 30 and 80 psi there. If it drops too low, and that switch tells the engine controller it's dropped too low, you lose your, don't quote me on those numbers, you'll have to, you know, dig into that. But the long and the short of it is, it reduces the power so that the injectors aren't working so hard if this pressure gets too low. Now there's your fuel temperature sensor, and that has to do with what's going on back here. And see that thermal recirculation valve is fully open until the temperature reaches 24 to 27 degrees Celsius, that's 75 to 80 Fahrenheit. And it's fully closed at 100 degrees Fahrenheit. At that point, all the fuel goes back to the tank. But it's doing the same job that that mechanical one used to do. You see what I mean? And there you can basically look at that, you know, at your leisure if you want to freeze the video and all that. I tried to make it big and clear so it would show out good for you. Now this 6.7 system fuel overhaul, this happens because of fuel contamination. As a matter of fact, if you look up the where you're wanting to buy a set of injectors and all, you're going to pay about nearly $5,000 for the stuff that you see on this bench. Of course, you know, some of these injectors haven't been unwrapped yet. And that's the high pressure fuel pump that you're going to replace. They're going to replace all the lines, the wire harness, both of those little rails over there. This one here has got the replacement stuff on there. All right, and this right here is what the kit looks like when you go online. You know, that's your wire harness, and this is all your little lines and all, and the lines that feed that. You replace every bit of that stuff. This is the pump, and that's the fuel control valve. That's the fuel pressure. That's the pressure control. That's the volume control valve. Is what it is. And these are your two pumps that are operating on little cams that are built into this pump housing here. But you're getting the whole thing. All right. So the main shaft has got two actuating lobes, and they're offset 180 degrees. Each pump piston is actuated twice per crankshaft revolution. And that's what the pump looks like when you unbolt it and pull it out of there. See, it's got a little roller cam on the bottom of it. By cycling the fuel volume regulator, just like on gasoline direct injection, you cycle the fuel volume, the engine controller cycles fuel volume regulator so that the pump is timed to the crankshaft and camshaft, and it optimizes the effects of the fuel pulses because it knows where these pistons are at all times. All right, you got that? All right, so, and there's that fuel volume control valve. All right, 6.7 liter replacement injectors must be coded to the engine controller. And these injectors I'm showing you here are for injector direct. The Ford ones come with a 10-digit code package with each injector, but these injector direct folks, they put this little QR looking code on here. And whenever Jimmy was, Ford had a supply problem getting injector, you know, getting fuel contamination kits over there, so they bought some from Injector Direct to put in the truck that he was working on. And so he was saying, well, I wonder where the numbers are for these. And I said, what about this little code? Because I noticed it was different on every injector. And Jimmy whipped out his smartphone and he shot that thing. Oh yeah, there's the code right there. I thought that was pretty cool. I thought it was sort of disgusting. I had an older phone than he did, and I could not shoot these codes and get that 10-digit. I mean, these little thing, barcode deals. But you see, that one's different from that one. It's different on every injector, and you got to put the 10-digit code in there whenever you're putting the injectors in there. You're telling it you're starting over. Now, what happened is, you got to read this. Gives you the 10-digit code. You're going to give the ECM. That's the one from Injector Direct. Now, you got to remember, they're slightly. You get the code from a different place on other ones, like on the Ford ones. It comes in the box with each injector. Each injector got a different code number, and the ECM needs to know which injector is in which position. So because it's constantly fine-tuning, you see, that's what that pressure control valve does on the rail too, part of it. Now that number provides it with injection quantity data, IQD, for each injector. It's a fuel trim thing, sort of like gas burners. If you don't do this, you'll get diagnostic trouble codes. And so just keep that in mind. 6.4 liter PSD injectors are interchangeable, just because of the way that's put together. It don't matter where you put those, you don't have to code anything and all that. Now the 6 liter injector, I had this in a previous PowerPoint, but look at the 6.4, how it's different. Basically, you don't have an intensifier piston because this thing comes in from the common rail already hot. Now this high pressure fuel, now this fuel comes in through the head on this one instead of through the line, and the oil comes from that rail and punches that piston down every time with using these two coils, and it moves that spool valve back and forth to control it. You can tell this is actually more complex in a lot of ways than this is, and there's more failure, there's more potential for failure in that injector than there is this one, at least from the looks of it. This is kind of like a Huey injector, but remember, unlike the Caterpillar injectors that the 7.3 had, this one was made by Siemens, that German company. There's no intensifier piston needed on this one here. This one right here is a 6.7 liter injector that's cut away. That's an actual injector that's laying there that Jimmy had on the bench the other day. And this right here is a cutaway version of it that I found. And you know, this has got the piezo discs and all in there. It's hard to cut one of these away and actually figure out what you're looking at there. You know, it's really handy and dandy for them to cut the darn thing away, but you're sitting here saying, well, what am I exactly looking at here? You know, it's not like you can build your own injector, but you might notice the body of this thing is really thick and robust because it has to hold all kinds of pressure. This has been a short video, but I hope you enjoyed it, and I hope you got something out of it, and there will be more next time, and I will see you then.